Alright guys, let's take a look at your warm-up for today. If you notice for both of these equations, we are solving equations involving logarithms. I'm looking at two specific types of logarithmic equations. The first one, if you notice, has only one singular log on one side. Log base 2 of 4x minus 3 is equal to 4. So if this occurs, so the first type, I'm going to put this type 1 is if there is only one log, period. What you're going to do is we're going to rewrite as an exponential in exponential form and then solve it. So remember, the way that you rewrite it, start with a base, jump the fence, that's the power, and jump the fence back, that's what it's equal to. So I'm going to have 2 to the 4th equals 4x minus 3. I can solve this. 2 to the 4th is 16 equals 4x minus 3. I'm going to add 3 to both sides, so that'll give me 19 is equal to 4x, and then divide by 4, and so that gives me my answer, x is equal to 19 over 4. And I could write that as a decimal, but I'm going to leave it as 19 over 4. Alright, so that's the first type. If there's only one log, period, you rewrite it as an exponential. Okay, let's look at the second one. For the second one, we're going to call this one type 2. And this is if there's one singular log on the left-hand side and one singular log on the right-hand side, they cancel each other out. So, for example, this is log base 6 on the left-hand side, log base 6 on the right-hand side. They cancel each other out, so that leaves me 5x plus 4 equals 10x minus 3. I'm going to solve this for x by subtracting 5x from both sides, so that gives me 5x minus 3. I'm going to solve this for x by adding 3, so I get 7 equals to 5x, and then I'm going to divide by 5, so that gives me 7 over 5. Okay, so far these are the only two types of logarithmic equations that we can solve. If there is only one logarithm, period, or if there's one singular log on the left and one singular log on the right. Well, unfortunately, these are not the only types of logarithmic equations. So, your essential question for today is, how do we solve logarithmic equations, and also, how do we apply logarithms to real-world problems? Just remember that you will have a test on Friday, and you will have a quiz on Wednesday. Now, this material will not be on the quiz, however, it will be on the test. Alright, let's jump right into it, and let's go over some notes right quick. You can only cross out the logs when there is a single log on the left-hand side and a single log on the right-hand side. So, for example, from the warm-up, the only reason why I could cross out these two logarithms is because there was one singular log on the left-hand side and one singular log on the right-hand side, and they were the same base, so they cross each other out. This is what's crucial. You cannot, I repeat, you cannot cross out all of these logs looking below. That's the most common mistake. People look at this problem and they say, oh, they're all base 5, so I'm going to just cross all of them out. No, you cannot do that. You can only cross out one log on the left and one log on the right. So, the way that you do this, you have to condense. That's why we learned how to condense. It's so that there is a single log on the left-hand side and a single log on the right-hand side. Now, for this problem, this right-hand side already had a singular log. So on the left-hand side, I would have to condense this to one singular log, and then I would be able to cross those two logs out, but only after I have condensed them. Okay? Alright, let's look at the example. I think it's the exact same problem. It is. So let's go back to this problem. So what I'm going to do first is I am going to condense this part of my equation. So notice that this is subtraction, so I'm going to condense that, write it as division, and also this 1/2 is the coefficient, so properties of logarithms, I'm just going to force that back to the exponent. So what I'm going to have here is log base 5 of x divided by 16 to the 1/2 power equals log base 5 of 25. Alright, now that I have one singular log on the left-hand side and the right-hand side, they cancel each other out. And remember, guys, 1/2 power means the square root. So 16 to the 1/2 means the square root of 16, which is 4. So I've got x over 4 equals to 25, and then to solve this for x, I just multiply by 4, and that would give me 100 as my answer. So see, not that bad, not that difficult. Alright, let's look at another problem. Alright, let's look at this one. Notice it's log of x plus 4 minus log of x equals log of 2. Again, guys, you cannot just simply cross these logs out. That is not a valid mathematical operation. What you have to do is condense the multiple logs on one side so that there's just one singular log. Also, just for review, even though there's not a base here, it's understood that all these bases are 10. Alright, now I'm going to rewrite this subtraction as division, so I'm going to have log of x plus 4 over x equals log of 2. Now that they have a singular log on the left-hand side and the right-hand side, they cross each other out. So that leaves me x plus 4 over x equals to 2. I want to solve this for x, so I'm just going to simply put this over 1 and cross multiply. So that will give me x plus 4 equals 2x. And then I'm just going to solve this for x by subtracting 1x from both sides. That will give me 4 equals 1x. So in other words, x is 4. And then that would be my answer for that problem. Alright, let's take a look at another one. I think I've got, yep, 2 more. Okay, alright, let's take a look at this one. It has log base 2 of x equals 1/2 log base 2 of 25 minus 1/3 log base 2 of 8. Again, I can't just cross these out. That is against the rules. That is not a legal operation. I'm going to need to condense this side. I notice this 1/2 is going to become the exponent. This 1/3 is going to become the exponent, and I'm going to rewrite this subtraction as division. So what I'm going to have here is log base 2 of x equals log base 2 of 25 to the 1/2 power, 8 to the 1/3 power. And then if you notice, the logs are the same on both sides, so they cross out, so that leaves me x equals, and remember 1/2 means square root, so 25 to the 1/2 means the square root of 25, which is 5, and then 8 to the 1/3 means the cube root, so the cube root of 8 is 2, and that's it. X is equal to 5 over 2. Alright, let's take a look at another one. Alright, for this one, it's log base 4 of x minus 1 plus log base 4 of 3 equals to 3. If you notice, I don't have a log on both sides. So that's going to go back. Remember when we did the warm-up? Let me go back to the warm-up. Remember type 1, if only one log, then you rewrite as an exponential. Well, we're still going to have to condense. So for this problem, we're still going to condense. We're going to condense the left-hand side. This plus, I'm going to rewrite that as multiplication. So I'm going to have log base 4 of, let me change colors so you can see it, 3, change colors, 3 times x minus 1, so that's going to give me 3x minus 3, and that's equal to 3. Now, in this case, I'm going to put that, I don't have a log on the right side to cancel out, so we're going to rewrite this as exponential form. So look at the base. The base is 4. Jump the fence. What's the power? Power's 3. Jump the fence back. What's it equal to? 3x minus 3. Work this out. 4 to the 3rd is 64 equals 3x minus 3. To solve this, I'm going to add 3, so I get 67 equals to 3x, and then divide by 3, so that gives me 67 over 3. And then that would be my final answer. So just remember, guys, for logarithmic equations, you can't just cross out all of those logs if you have multiple logs. You have to start by condensing. Once you condense it down, then it's going to fit into one of those two types of categories, either where you have to rewrite it in exponential form or where you're able to cross them out. All right, the second half of your central question was about word problems. So let's take a look at this word problem about aviation. It says the altitude of an aircraft is in part affected by the outside air pressure and can be determined by the equation below. So this is the equation that it's referring to. All right. where H is the altitude in miles, P is the air pressure outside the aircraft, and B is the air pressure at sea level. Normally, the air pressure at sea level, or B, is 14.7 pounds per square inch. You do know that as you go up, so like if you drive up to the mountains, the reason why your ears pop is because there's not as much air pressure there, and so your body's having to compensate. That's also why if you ride an airplane, they have to pressurize the cabin, because the higher in altitude you go, the less air pressure there is. So they have to find a way to standardize that. All right, it says, suppose the air pressure outside of the airplane is 10.3. What is the altitude of the plane? So for this problem, it wants you to figure out what the altitude or height is. Now, a couple of things it does tell us. It does tell us that B is 14.7, and it says the outside air pressure, or P, is 10.3. So it wants to know how high this airplane is. So I'm going to use my formula, H equals negative 100 over 9 log of 10.3 over 14.7. All right, and we're going to use our handy-dandy graphing calculator to help us do this. Notice that even though there's not a base here for the log, it's understood to be 10. Okay, all right, let me minimize this, bring it down. All right, and then let me... All right, guys, so using my graphing calculator, what I'm going to do is I'm going to try and type this in to figure out what my altitude will be. So I'm going to hit Control Divide and do negative 100 over 9, then go off to the side and hit times, and I'm going to do Control Log. Now I can leave that base blank because the calculator will automatically assume that that base is 10. And then I want to do 10.3 over 14.7. So I'm going to hit Control Divide 10.3 over 14.7. And if I hit Enter, it gives me 1.716. So 1.716 miles. So it's almost 2 miles in the air. And that would be the answer for that problem. All right, let's look at one more word problem. And it's about money. It says, Mr. Kelly invests $2,000 at a rate of 4.5% interest compounded yearly. That means every year they add interest to my account. It says approximately how many years will he have to invest his money in order to have $10,000. So I want to know how many years, or T for time. So I want to solve this for T. Now A represents the ending amount, which in this case would be $10,000. P stands for the principal or starting amount, which in this case would be $2,000. And R represents the rate, which is 4.5%, but you have to represent that as a decimal, so that would be 0.045. So let's write this equation out. I'm going to have 10,000 equals 2,000, 1 plus 0.045 to the T. Now remember, guys, you're trying to solve this for T. Well, T is an exponent, so I have to somehow bring this T out. So that's where we know we're going to use logarithms to help us. But before we can do that, what I'm going to do is I'm going to clean this up a little bit. I'm going to remember my PEMDAS, and so I'm going to do what's inside of parentheses, so that's going to give me 1.045. And then to solve this for T first, I'm going to divide by 2,000, and so 10,000 divided by 2,000 is 5, and then that leaves me 1.045 to the T. And now to bring this exponent T out in front, I know that I'm going to have to use a property of log, so I'm going to log both sides. And when I do that, this T is going to come out in front and become the new coefficient. So I'm going to have log 5 equals T log of 1.045, and then to solve this for T, I'm just going to divide by log of 1.045. Now, even though it doesn't say what base it is, it's understood to be a base 10. All right, so let's work this out. I'm going to hit Control Divide. Let me get my calculator. Control Divide, and I'm going to put log, and again, you can leave the base alone, of 5, and then log, and I can leave the base alone because the calculator will automatically assume it's a base of 10 of 1.045. So 1.045, and I hit enter. And good grief, it's going to take me approximately 36.5 years to get that money. So I better start saving now. Okay, guys, that ends our notes for today. If you had a little problem with it, just go back and rewatch the video, and you can ask me questions when I return. All right, thanks, and get ready for your classwork.